Welcome! We've created this tutorial to walk you through the adjustments of motion-controlled terminal devices and electric wrist rotators. Whether this is your first time with a motion control device, or you fit them in the past but need a refresher, this will be helpful. I provided patient care for several decades, and of course lower limb was the bulk of my patient load. So when an upper limb patient would come into the clinic, I would need to open up the manuals and quickly retrain myself. We're going to approach this tutorial as if we're caring for a new amputee receiving their first myoelectric prosthesis. Many times these are the toughest patients with atrophied muscles, weak signals, and crosstalk between antagonistic muscles. The motion control user interface allows quick, easy adjustability of the device to maintain optimal proportional control throughout the rehabilitation process. All motion control devices have proportional control. A small muscle signal moves the device slowly, a stronger contraction more quickly. This has been proven multiple times to be much more functional than simple on-off devices. For optimal proportional control, many parameters can and need to be adjusted. Add to that hand-wrist switching, and even more adjustments are necessary. We saw the need for this adjustability with the introduction of the Pro Control 30 years ago. At that time, those adjustments were made by tiny gain pots. Soon, with microprocessor control in the Pro Control 2, those adjustments were made with a laptop computer. Now, with the computing power of an iPhone, those adjustments can be made in the palm of your hand. The Motion Control User Interface is an easy-to-use app that can be downloaded onto your iPhone, iPad, or inexpensive iPod Touch. While it is easy to use, there is terminology and technique involved. We will go through those techniques, and a glossary of terms is available from Motion Control. With early systems, those adjustments were made in small gain pots. Soon, with microprocessor control, we could do it on the laptop. Now, with the computing power of an iPhone, we can put that adjustability in the palm of your hand. The Motion Control User Interface is an easy-to-use app that can be downloaded on your iPhone, iPad, or inexpensive iPod Touch. While it is easy to use, there is terminology and technique involved. We'll go through these techniques in the video, and a glossary of terms is also available from Motion Control. When you receive a Motion Control Pro Plus device, it will come with a Prosthetist manual and a user guide. The user guide should be given to the patient as it has information on appropriate use of the device and warnings on incorrect usage. The Prosthetist manual has not only important information about the device, it also has instructions on downloading the iOS app from the App Store and the Prosthetist key. Also included is the Bluetooth certificate with the pairing key. If this information does get lost, it is available by calling Motion Control. The instructions for MCUI are located on the last page of the Prosthetist manual and user guide. There are adjustments your patients can make to their device, so make sure you help them connect. To load the app onto your iOS device, go to the App Store and search MCUI. The app is the one with the hand icon. Now you can download it. You may need your iTunes login and password. The app is free. Once it's downloaded, it will ask to use Bluetooth. Check OK. Next, it will ask to send you notifications. Allow. We do not send out advertisements or any notifications that are not necessary for the function of the app. Next, it will ask if you are a patient or a prosthetist. If you select patient, only a portion of the adjustments are available. Click OK, and then you are asked if you would like to take the tutorial. The app is now ready to be used. Areas that are grayed out are adjustments the patient are not allowed to make. Areas that are bright can be changed. These are patient-specific adjustments. If you choose prosthetist, you will be asked to enter the prosthetist access key. This can be found in the Prosthetist manual packaged with the device. Once the access key is entered into an iOS device, it will be remembered in that device and you will not be required to enter it again. If you would like to use a different iOS device, say your iPhone, you will be required to type in the access key again. Next, you are asked if you would like to take the tutorial. This will give you a quick overview of a few functions of the app, but we're going to do a much deeper dive. The Scan button will initiate a search for available motion control devices. Tap the button and the arrow will begin to spin as it searches for devices. As they are discovered, they will appear below the simulation program. To choose a device, simply tap on it. If a device does not show up on the screen, make sure the device has a fully charged battery and is turned on. Tap the motion control ETD. To connect to a device the first time, you will need to enter the pairing key we saw packaged with the device. It may take a few minutes to pair the device. Then, success! On the iPad, this automatically takes you to the main page. With an iPhone, it will take you to the main menu page. By tapping an icon, you will go to those adjustments. Some menus are device-specific. Terminal devices do not have switch controls found in powered wrists, so that menu is grayed. Wrists do not have flag, so it is grayed out when adjusting wrist units, but highlighted since this terminal device has flag. The powered Flexion wrist has its own specific set of adjustments. For this tutorial, we will use the iPad since all the adjustments are on one screen. Just remember, with the iPhone, you will need to jump back and forth to the main menu. Remember, we are setting up the device for a new patient, so let's go to the ProWrist first. It has its own microprocessor and therefore its own pairing key. It first warns us that the terminal device and the wrist have different settings. That is likely okay, but it can cause issues. If I tap Devices, it opens the screen showing which device we are connected to, and I can easily switch between devices by tapping whichever device I want to adjust. Notice at the top of the screen, it always tells you which device you are adjusting. Make sure you are not trying to adjust the terminal device while connected to the wrist microprocessor, or vice versa. We are starting with Setup in the ProWrist. If I drop down the menu under Wrist Setup Continued, I can enable or disable the wrist rotator. Since our fictional patient is receiving their first myoelectric device, we're going to start by disabling the electric wrist. This will prevent the patient from accidentally switching to the wrist, and then the frustration of trying to switch back to the terminal device. Hand-wrist switching is one of the most difficult things for a patient to learn. Now let's go back to adjusting the terminal device. To begin, we need to set up the device. Setup is on the left side of the screen. Notice the small icons throughout the page. If I tap on the eye, it will open a balloon and give me a synopsis of what that setting or adjustment does. When I open up the menu for hand setup, the first choice is EMG versus non-EMG. EMG devices would be electrodes. These can be any filtered electrodes. Motion control, triad preamps, Autobach, Touch Bionics, almost any manufacturer's electrodes will work. At motion control, we understand the need for interchangeability, especially in the small field of upper limb myoelectric components. Non-EMG inputs would be for a case where there are no EMG signals, maybe a degloving injury or severe nerve damage, where you need an alternative method from EMG. A linear potentiometer installed in a harness or touchpads installed the socket can be used. These inputs still provide a proportional signal for quick speed combined with fine control. But in this case, we are able to use EMG. Next is filtering. Quick, medium, or smooth. EMG signals especially are very noisy signals. Filtering does just that, filters out the noise. As you filter noise, smoothness improves, but responsiveness slows down. Our new patient will likely do well with the smooth setting because they have not developed that fine control yet. A more seasoned wearer who wants a more responsive device might like a quick setting. The next setting is single channel versus dual channel. Dual channel is the most intuitive and natural for the patient, but sometimes due to the nature of the injury, only one EMG site is present. We have several algorithms to operate a terminal device using just one muscle or single input device. If you're confronted with a patient with only one EMG site, please call us and we will help walk you through the best system for your patient. Next down the list is control, differential versus first over. This is a very powerful setting. This is how the patient controls the prosthesis, not only open-close, but also the speed of the device. Originally, motion control devices were all differential control. They would look at the difference between the two signals. Let's say A channel is wrist extensors, B channels is wrist flexors. The device looks at A channel minus the B channel. The equation is then A minus B equals the direction and speed of the device. When the patient fires wrist extensors, A channel is 100%, B channel is 10%. The result is 90. The hand opens quickly. Conversely, if the patient fires the wrist flexors, A channel is then 10% and B channel is now 100%. The result is negative 90. The hand closes quickly. If the patient is trying to gently grasp an object, A is 10% and B is 30%. The result is negative 20 and the hand closes slowly and controllably. A very nice system. But in many cases, and especially our fictional first-time myoelectric wearer, there is significant crosstalk between antagonistic muscles. So maybe the patient can open the hand just fine, but when they attempt to close the hand, both extensor and flexors fire equally, and the resultant equation is 50% minus 50% equals 0, and the hand doesn't move. A very common problem. We've given you a powerful tool, first over. In this setting, it will read the first muscle that fires and ignore the other signal. So in our last case, when trying to close the hand and both channels are at 50, 50 minus 50 equals 0, it ignores the A channel because the B channel came up first and the equation looks like this. Now the hand closes. This happens to whichever signal hits the threshold first. We will discuss threshold momentarily. The disadvantage is if the patient wants to switch directions, say go from opening the hand to closing on an object, they must first relax, then fire the wrist flexors. I spend a lot of time on this because let's bring it back to our fictional first-time wearer. They are very likely to have crosstalk. I'm going to start them out on first over. If they prove to have good separation of signals, then I can switch them to differential control so they can switch direction quickly and easily, but I want that initial experience to be positive with as little frustration as possible. Finally, in the setup menu is hand direction. When starting out, I do not know if A channel is open or closed. With my new patient, I'm going to ask them to extend the wrist and watch what the ETD does. Oftentimes, they can do this with their phantom limb. It also helps if they do the same motion with the contralateral side. Then flex the wrist. It is a 50-50 chance it will open with extension and close with flexion. This lets me see if it's wired correctly. If it is backwards, extension is closing the ETD, I can simply switch polarity and this will get the ETD going in the correct direction. Also, my fictional patient does not know what muscles make the hand open or close. This lays the groundwork. They learn wrist extension opens the hand, wrist flexion closes the hand. Soon I'm going to change my words to hand open, hand close, once I'm sure it's wired correctly and the patient understands the muscles involved in opening and closing. To recap setup on our fictional first-time wearer, I have it set on EMG dual channel because they have two distinct signals. Filtering is smooth to give them as fine a control as possible, and first over because I know it is likely they will have crosstalk between their muscles. And I've double-checked to make sure wrist extensors open the device and flexors close the device. We now have the device set up. On the right side of the screen, we have the Channels menu. On an iPhone, we would go back to the main menu and choose Channels. The first adjustment is Thresholds Outputs. The output is the strength of the signal as shown by the red bar. As the muscle fires, you can see the signal rise corresponding to opening and closing the device. The slider is the threshold. Any signal below the threshold does not cause any movement in the device. A common use for this adjustment, let's consider the short transradial amniotic band syndrome patient. Many times these individuals flex and extend the elbow, artifact signal slips through. The terminal device could open while they flex the elbow. We can raise the threshold so that when the muscle inadvertently fires, it does not move the terminal device. Now, if we get it too high, the range for the patient is very small and proportionality is lost. We want to keep this level as low as possible, down to about 20%, but yet cancel out any inadvertent muscle signals. Notice too, if I simply tap the square, I can now key in an exact number. Also remember, when the device is set to first over, the first signal to cross the threshold causes motion. The other channel is ignored. When there is a lot of crosstalk, I can lower the threshold on the channel we want to move. Effectively, we shorten the racetrack to that threshold. So threshold, anything below the threshold, the device does not move. Also, on first over, the first signal to hit threshold, the other channel is ignored. Next is gains. The gain is our volume control. If one muscle, say the extensors are very strong, but flexors are very weak, I can turn up the gain on the flexors to amplify that signal. Thus, a very weak muscle, common in our new patient, can still control the device. Conversely, if a gain setting is too high, the device moves too quickly and the patient has no control. In this case, the gain needs to be turned down. So working with our fictional patient, ask them, can you open the TD? Can you close the TD? Is it easier to open or close? The patient may say it's really hard to open, in which case I would turn up the gain on the channel for opening the hand. Or they may say it's really easy to close. I'd turn that gain down. At some point, it will be feels about the same. When they get to that point, awesome. Our new patient is usually very excited, happy, family members are excited, there might even be a few tears. That's why we do this. But we're not done yet. We don't want them crushing objects, so they need that fine control. I'll ask them to close halfway. Almost always the device will snap shut. Okay, again, and close halfway. It snaps shut again. This is when you start turning down the gain. Now they can control the device much better. Close halfway, now close halfway again, halfway again. That is the fine control you're wanting. Now this may not be possible on the first visit, and if not, we have some other tools and tricks for you. So the gains are the strength of the signal. A weak signal that isn't strong enough to move the device can be amplified to be a strong signal to attain full speed at 100%. A strong muscle can be made more controllable by turning down the gain. Motor power at the bottom of the screen shows how much power is going to the motor. It could be open or closed. And the yellow light power save is a feature that once the device stops moving, it cuts power to the motor so it doesn't run down the battery. These two items you will seldom use, but could be necessary during troubleshooting when speaking with one of our technicians. Below the channels, there is another drop-down, Flag. On the iPhone, go back to the main menu and tap the flag icon. Let's imagine our fictional patient again, new to myoelectrics, and they are struggling on their first day with fine control. They're doing great at open-close, but everything they grasp, they immediately crush with full pinch force. It is going to take some additional time to learn fine, proportional control. In the meantime, we've given you a tool, Flag, Force Limiting Auto Grasp. So now, when I hold the TD open for a period of time, you hear a buzz. That lets the user know Flag is now turned on. When I close, it moves at half speed, and when it contacts an object, the amount of pinch force limits to about 2 pounds of force, and there's a buzz. If I give it a closed signal, another 2 pounds of pinch force are added, and it buzzes to let me know. I can pulse up to 10 times to grasp an object tight enough. With an open signal, the ETD simply opens. This gives our new fictional patient confidence to grasp an object without concern of crushing it, be it a full water bottle or a child's hand. Additionally, A seasoned wearer that has good fine control can now just feel for the buzz rather than have to concentrate on how tight they are pinching. It reduces cognitive load. One of our field trials was a gentleman who tied flies with his ETD. With 1 or 2 buzzes, he could tell how tight he was holding a delicate feather. Another field trial participant spent time in the kitchen. With flag on, she could now just make it buzz a couple times and know she was holding a baguette tight enough without smashing it. Additionally, flag has an auto grasp feature. If the system sees an inadvertent open signal, it will actually close slightly rather than open, preventing a person from dropping an object with an accidental open signal. To turn flag back off, again hold open, and there are 2 buzzes. That lets the user know they are back in proportional control with immediate full pinch force. So let's look at the flag menu. Many of these adjustments the wearer can change. To start with, flag can be completely disabled, so when the TD sees a long hold open signal, flag will not turn on. As soon as I turn it off, all the adjustments go away. Turning it back on, the first adjustment is flag threshold. Any flag action, whether it is hold open to turn flag on or a pulse to increase the pinch force, the signal must be above this threshold, in this case at least 78%. Next is hold open time. This is adjustable from 1 to 3.5 seconds. Usually something around 2 seconds is adequate, but it goes up to 3.5 seconds for use with COAP pattern recognition systems. Next is pulse time, the period of time a closed signal is needed for an increase of pinch force. And finally, force increment, how much tighter it holds the object with each pulse. The feedback buzzer can be turned on or off. Auto grasp can be disabled. With auto grasp on, there is a 0.6 of a second delay. Some users do not like that delay, so it can be disabled. Notice too, when flag is on, speed slows to half speed. One of our first field trial wearers did not like that and still wanted proportional control. With this set to high, it now runs proportionally up to full speed. And finally, if the settings get out of whack, the user can just hit reset and all the flag adjustments go back to factory default. One other important point with flag. If the user attempts to turn on flag and they get 5 buzzes, that means something may be amiss. The first solution is to close to full pinch force at least once and then hold open again. This should solve the problem. The processor wants to check the sensor in flag to make sure it is working correctly each time the TD is turned on. It does this with a full pinch force close. If it hasn't closed to full pinch force, it will give the 5 buzzes. If after a few attempts at full pinch force you still get the 5 buzzes, something is indeed wrong with the flag sensor and the TD needs to come back to motion control for repair. The terminal device will still work fine, the user will just not be able to turn flag on. Flag is optional and available on the ETD, ETD2, and the motion control hand. Flag has become a very popular option. Let's now switch to the wrist rotator. In the iPad, it is at the top of the setup screen. On the iPhone, scroll to the bottom of the main menu page. If we go back up to the top, we can again start with setup. Remember, we disabled the wrist. Let's enable it. On the iPad version, remember it's down in the wrist setup continued section. The rest of the settings on this page are identical to the terminal device. Even if the terminal device is set to differential control, it is okay to set the wrist to first over. It is difficult to pronate and supinate the wrist using wrist flexion extension. Thus, there is often more crosstalk with wrist rotation than open-close. There is another drop-down menu, Switch Control. That gives you 2 methods for hand-wrist switching, co-contraction or fast access. Let's start by switching to co-contraction. Now it will switch from terminal device to wrist with first a relaxation, then a quick contraction of both muscles, and then relaxation again. When the correct co-contraction is hit, the wrist will make a buzz and switch to the wrist. The same process will switch from wrist back to the terminal device. On the channel side of the screen, you can drop down Switch. There you will see switch rates. The switch rates show the speed of the contraction. It isn't a strong contraction, but a quick contraction. The lower the switch rate is set, the easier it is to switch. The higher, the more difficult. Both must hit the switch rate setting within the time of the switch window. You want the switch rates low enough that the patient can easily switch from hand to wrist and vice versa. If it is too easy, they will accidentally switch when opening or closing the ETD or rotating the wrist. Notice auto switchback is turned on and the auto switch delay begins to count down once the patient relaxes. With auto switchback turned on, if the patient relaxes the amount of time on the timer, it will automatically switch from wrist control back to the terminal device. This is in case the patient forgets they were in wrist and reaches to pick up an object, the wrist doesn't rotate and knock the object over because it has automatically switched back to the terminal device. Conversely, some patients know once they switch to the wrist, they are in wrist and want to know exactly where they last were. The other method of hand-wrist switching available is fast access. If we tap that button, co-contraction is automatically switched off. With fast access, only one muscle must go over the switch rate in order to switch to wrist, and the wrist immediately begins moving. The pattern here is relax, one quick muscle, and the wrist begins turning. The patient can run the wrist in both directions, and it will not switch back to the terminal device until the patient relaxes for the time set in the relax timer in the channel's window. So to demonstrate, a fast open signal and the wrist begins to supinate, then compronate. A relaxation, in this case for 0.7 of a second, it switches back to the TD, and now slow signal opens and closes the hand. So which to use? For a new patient, co-contraction is the easiest to explain and learn. I will often start with co-contraction. Functionally, fast access works better. A user can walk up to an object and with a fast contraction position the TD. Relax for a split second and with a slow contraction grasp the object. It can be frustrating for the new patient to learn though. Our last device is powered Flexion wrist. This is a new product for us and has some very nice features. We at Motion Control have long been proponents of wrist flexion. It is very important to be able to get into midline of the body and position the TD for many daily tasks. Powered Flexion wrist allows this without the involvement of the contralateral limb. Powered Flexion wrist is available with all Motion Control terminal devices, the MC hand, ETD, and ETD2. The Powered Flexion wrist is mounted directly to the terminal device. The Powered Flexion wrist is the same length as a powered wrist rotator. All of the settings are identical to the pages we have already discussed, including hand-wrist switching described with the wrist rotator. But there is a special menu for Powered Flexion wrist. The patient has access to all of these adjustments. First, you will see speed is adjustable. This is a patient preference so that they can get it in position quickly enough, but yet stop with precision. Motor brake is for increased passive resistance. Next is home position delay. As the wrist moves through its range, it will delay at any spot the patient would like. The timer is how long it will delay in this spot. To set where it pauses, the patient passively moves the TD to the position they would like it to pause, and then touch current position. This is now home and where the wrist will pause. The default position is 25 degrees of flexion. This pause gives the patient knowledge of where the terminal device is in its range without needing to see it. Finally, calibrate range of motion. An extension stop is available if the patient would like to carry heavier weights. When the stop is installed or removed, the wrist needs to be recalibrated. That is a lot of information and new terms. We have a glossary of terms available and it can be very helpful. Please contact us at Motion Control. For an even more in-depth course on myoelectric upper limb prostheses, Motion Control sponsors MyoU every spring and fall in Salt Lake City. This is a 4-day course covering casting, fitting, and adjustment of transradial, transhumeral, and shoulder disarticulation amputations. We provide patient models, or you are welcome to bring a patient you are actively fitting. Every attendee casts and fits a prosthetic socket, a true hands-on course. Please contact us for dates and availability. Myoelectric fittings are complex with a lot of specific knowledge necessary. With preparation and study, they are enjoyable, rewarding cases to be involved with. But going into them without preparation, they are frustrating not only for the prosthetist, but especially for the patient. Hopefully this training video has helped increase the chances for a successful outcome. Thank you.